In this video, let's see about inserting an element into an array. So this is another primitive function that helps us to append or insert a new element into an existing set of elements that are stored under the data structure array. So before looking into insertion, one important point that should be remembered is elements in the array must be stored in contiguous locations, and these should not be there should not be any empty or null locations or null values in between the array elements. So this is because the element in the array will be accessed with the logical addresses, that is the index value multiplied by the size of the element and added with its base address. So this we have seen in the previous videos, like how actually the physical addresses are arrived with the help of the array indices that are nothing but the logical addresses which the user uses to access any particular element in the array. So let's see an example how actually the array elements are accessed with the help of the base address in the array index. So let's take an example array. Say for example we have 20, 25, 36 and 10 stored in location 0, 1, 2 and 3. So here these are the logical addresses or the index or locations referred by the programmer, and this is not going to be the same when it comes to the physical addresses. So physical addresses are going to be a bit different. So these same set of values are going to be stored physically at location say 1000, 1001, 1002 and 1000. Let's assume. So all in hexadecimal. Okay. So this is the physical address where we can find the elements in the memory. Now look at these physical addresses. See, this logical address 0 should be mapped to this physical address 1000. This logical address 1 should be mapped to 1001. Logical address 2 should be mapped to 1002. And logical address 3 should be mapped to 1003. And this is all these set of values are stored under the array name A. So array A is stored with these values, say 20, 25, 36 and 10. And the indices gives us the logical addresses, and these values are the physical values. So just by looking at this name, we could say that this is a simple variable which can hold one value at any given time. And this A cannot store the address of each and every element, but then it is going to store only one address. So the one address that is going to be pushed into this variable A is nothing but the starting address of the list of elements that are stored under this array name A. So A is going to have 1000 stored in it, which we call as base address. Right? So this base address is going to be used for used for accessing all other elements in the list. So we are not going to store the addresses of every element. Instead we store only address of the first element of the array. So whenever the programmer refers to say some element, say which is 36 here located at index 2, he say that pick A of 2, or he will just try to access 36 by having this a representation A of 2. So this logical address 2 has to be converted into physical address 1002. This 2 will not help us in any way to get this address 1002 directly. But how the system works at the back end is, it knows where the array starts. So the array starts at 1000. The first element of the array is at 1000. Then We also know the size of every element in the array. We know that the array is a homogeneous structure, meaning that every element of the array should be of same type. If you have stored, say, a set of values, then these set of values can either be integers, all integers, or all real numbers, or all complex values, something like that. So here, size of the element and the array is known to us. So here we take the size of the element to be 1 byte each. Right? So now, taking the size of the element to be 1 byte and knowing that the starting address is 1000, with the help of this index 2, which is the logical address given by the programmer, we could directly move to 1002. Let's see how we could do that. So we know the base address, just have the base address as such, and add this 2 multiplied by the size. So you get 1002, which is the location, the physical address where you can find 36, which is nothing but A of 2. Right? So here, this base address or one single address that is stored in the name of the array, and the size of every element and this logical address will help us to get the physical address of any number or any element of the array that is stored in the physical memory. So here it is enough just to store the starting address, because every other element is continuously stored. Say for example, you have these elements 20, 25, 36 and 10 with locations say 25 stored at 0, and say you have location 1, 2 and 3 empty, and at location you store 20, and say at location you store 10, and you skip few locations, and at random location 8 you store 36. Now with this arrangement of data, will we be able to access the elements just with the index and the base address? The starting address, again, let's assume that to be 1000. So if I just try to take the second element, which is nothing but 25 here, this second element's address, will we be able to get the address of the second element with this base address and the index 2? No, not possible. So it is randomly stored. So when the elements are stored randomly, and if you have this null or blank positions in between the array, then it is going to be extremely difficult to access all the elements in the array just by knowing one address. So this is the reason why the elements in the array should be stored continuously without leaving any space in between. So we always need to store the elements in order continuously in physical memory. So here it goes like this, always 20, 25, 36 and 10 in order, and the starting address could be anything, like we can also have the starting address to be say 10,000 10H, and it could be, the next should be at 11H, and next can be at 12 and 13. So this is nothing but the physical address what we mentioned. So these are all the physical addresses. Right? So here I hope now you understood why the values in the elements or the array elements must be stored continuously. Now let's see how we can actually insert an element. Supposing we have some set of values that is stored in the array, and we try to insert a new element in between the existing values. So question be like this, like insert, say sum 28 at location 2 in array A of size 10, whose values are 26, 36, 48. You have currently 4 elements, say 26, 36, 48 and 58. So these are the elements now we currently have, and the indices would be 0, 1, 2, 3. And the other locations, say 4, 5, 6, 7, 8 and 9 are empty. This is allowed. Having empty spaces after the list of values in the array is allowed. But having this empty space somewhere here in between the data is not allowed, in which case we say that the array is polluted or corrupted. So we always call it as a hole in between the elements, so which is not allowed, which is not acceptable here. Now trying to insert 28 at location 2. This is what the question demands. So we need to insert 28 here at 2. So how can we do this? So there are 2 solutions possible. So first solution is, solution 1 is just move this 48, to location 4, which is currently empty. So you just create a space here. So when you just move this 45 to location 4, then you have a space created here which could now accommodate 28. So now we can have 28. Right? But then here we have a problem that we do not maintain the order of the elements. So as per the actual list, 48 should appear before 58, whereas when you just move this 48 to take up a new position in order to have a space created to insert this 28, you lose the order of the elements, so which is not agreed. So we have to insert this 28 and also retain the order. Without changing the order of the elements, we have to do this insertion. Then the solution would sound like this. The second solution is having the elements moved one position down. So here you have the index is shown, right, tilting, and the elements are (20), 6, 36, 48 and 58. So what we do here is, in order to preserve the order and also create a space to accommodate 28, what we do is we just try to move this 58 one position down. Move this 58 one position down. So move it here. So you get 58 here. And this is going to become empty. And move this 48 one position down. So in place of 58, now you're going to have 48. Now you're supposed to add this at location 2. Location 2 has now become empty. Stop the movement of data and insert the element to be added here. Just insert 28. And these values will retain its position and it will not be touched. So now you have a new list wherein the order of the elements are preserved and also a new element has been inserted. So this is the other way of doing it, where actually we also create a space without changing the order of the element or preserving the order of the data that is already existing in the list. So now let's see how can we go about writing an algorithm for this method or the second solution. So this solution is not going to help us because it is changing, the order is not preserved. So order of the element, order is not preserved. So we are not going to use this. So we are going to use this solution. Now let's try to develop an algorithm for this. So how can we go about writing an algorithm for implementing this logic? The logic is very simple. See here, you first have to find out whether you can accommodate this new value into the list. So if the array is already full, if the array has got all 10 positions filled with elements, then there is no space for this 28. This 28 or new element cannot be added into the existing element. So the first thing you need to understand is just check whether you can accommodate this new element, whether so first thing we need to do is check for space to accommodate the data. So if you have enough space to accommodate, then you have to know the actual length of the array. The actual length of the array should be known. So which is nothing but the current number of elements. Right? So this must be known. Only then we will be able to understand from which particular position the element has to be moved. So here we have actually 10 locations. So it is not 10, it is 9. It should be 9 because we start the index from 0. So from 0 to 9 we have first 5 positions fill. First 4 positions fill from 0 to 3. The other remaining positions are empty. So we have to start the movement of data from 3. So this could be done only if you know the actual length of the array. The actual length of the array is 4. The declared size is 10, whereas the actual number of elements currently available in the arrays will be 4. So you have to start moving data from location 2. So if there are total number of elements are 4, then it is going to be from 0 to 3. Right? So you have to start the movement of data from location 3. So making it general, assuming that the length of the array is k. That is, which is going to get us the number of key values stored in the array. So let's take this to be k. Now we know that the starting index is going to be 0. So we need some index position or index variable so that we keep changing it and we try to keep move the data one position down at every step.